in today's webinar. My name is Joseph. I'll be speaking with Chris Dunn today about linking passengers and user needs, a model for rail system advisory. Before I introduce myself, I want to talk about why this topic, because resilience today, especially for railways, is very critical, and it's a big part of what our clients are facing under the current situation. Dropping passenger numbers and running trains on time when their staff may not be attending work, etc. So today's webinar is really about how we advise our clients, especially rail operators, at times of uncertainty and adversity. So my name's Joseph Wong. I have 25 years of experience in railway engineering. Mainly on testing, installation, commissioning, design. I'm also an in-house technical expert on signaling and train control in China and maybe the region in Asia. I've extensive experience in the design maintenance. So that's why in the last few years, I've worked on and pioneered asset management in Asia, especially for railways. I was a past chairman of the railway section of the IET Hong Kong chapter and still a committee member. And Chris, my partner today, he's a senior engineer in the region in China now, and he will be advising our clients in Singapore very soon. Chris has a lot of years of experience working on rail advisory with various rail operators in the region. He advises on life cycle, design installation, as well as assets and maintenance. He has diverse experience in Australia, Asia, Middle East, and UK. So right now I'm in Hong Kong and Chris is in Malaysia working in a Malaysian project. So let's start. We're often asked to solve a railway problem of enhancing resilience in the face of crisis. Crisis events, those that shock the system, railway system, can occur from a variety of sources, such as complex systems that manage our railways, changes in our climate, or even a pandemic like we do have now. But such events are hard to predict and often occur as a series of complex, unknown, evolving circumstances, where such an event might occur, but we can't tell how that will evolve into crisis. So the best way we can do is try to predict it, prevent it, or recover rapidly afterwards. Today, we are presenting one of the models that we have used, especially in the last 2 or 3 years, for rail systems advisory to help solve the problems of enhancing the resilience of railways to the occurrence of a crisis. Our model helps us map out where complex unknown events can be found, giving us the tools that we can use to enhance resilience to these events. So I'll now pass to Chris, who will talk about the methodology and some examples to begin with.
Thanks, Joseph. Yep, thanks, Joseph. So opportunities to enhance resilience need to be explored in order to mitigate these crises. As Joseph mentioned, these are those complex, unknown series of events that we really don't yet know about. And resilience in the face of crisis may require unknown or complex solutions. So where do we go about finding these solutions? For our model, we borrowed a map from the Project Management Institute that helps guide us towards uncovering the unknowns of a problem. It starts with the requirements and the outcomes of those requirements that we're very familiar with. It guides us towards methodologies that we can use to explore more complexity where the outcomes aren't always clear. And then it drives us towards these unknowns, the complexity in a problem that can allow a crisis to occur. So this is our map. On one dimension, we have the input requirements of our problem. And on the other dimension, we have what represents the outcomes of the project, having followed those requirements and solved the problem. We start our problem solving in this known area. These are typically the requirements of a railway that we know and the solutions and outcomes to railway problems that are also well known. And this is where we find our basic passenger needs. Often the requirements we work with are rooted in these passenger needs. So, for example, the passenger need for timeliness, for arriving at their destination on time, and for having a journey that's not been delayed, and having a highly available train system that can carry them and compete with other transport methods, a reliable system that won't break down. Passengers also need safety and health. When we think about this from a rail systems engineering point of view, we often think about system safety, such as ensuring the railway doesn't harm or injure passengers, making sure trains don't crash. But health is one of those unknown areas that has migrated over to a known area since the pandemic. And we find this coming up more often in passenger requirements these days to consider the health aspects of the system. And cost and seeking environmentally sustainable transport is another basic passenger need we're encountering. So we often have known outcomes that meet these requirements as well, such as providing a predictable, regular, fast train service, using highly automated rail systems, and even things such as regular cleaning, germ-resistant surfaces, and using energy recovery systems to enhance the sustainability. We typically have solutions that we know about to meet these basic passenger needs. So secondly, we shift into venturing into the complex. These are often our engineering methodologies, our rail systems engineering methodologies that we can apply to a problem to come out with a solution, even if we didn't know what that outcome would be when we started. So for some examples of where we've applied methodologies like this recently, in our team, we do things such as simulations, where we simulate the headway of a rail line to uncover a solution for a signaling system. Or we simulate the traction power needs of a railway line to come up with the power draw solution. We also conduct RAMS analysis, so that gives us the opportunity to demonstrate how reliable and available and safe that system would be. Value engineering is another tool that we've used to solve rail systems problems recently, so that we can explore some of these unknown options, and value engineering being one of those techniques that we can use to figure out some unknowns and come up with a good solution. We also do asset management assessment, and Joseph's planning to talk about this later on, so stay tuned. But then we move on to our last box. So when we come to exploring the unknown to solve our problem of enhancing resilience, we're really looking at exploring how to prevent and protect against a crisis, how to improve the rapid recovery of a system, and how to make a system adaptable to change. And for a rail system, in our experience, there aren't really well-known solutions to these problems. There isn't a methodology that can be followed. There's no standards written about it to prevent any crisis in general. There isn't a well-defined methodology for recovery either. We find there are guidelines and possibilities, but the requirements involved in these are really vast. And we don't know what the requirements or outcomes are going to be for every scenario. So there are unforeseen things as well. I mentioned earlier about passenger health. If we surveyed passengers 2 years ago, health wasn't a highly rated item, but now it's right near the top of surveys onto what passengers are looking for. So some of the tools that we use to reliably explore this unknown area are to welcome changing requirements and to respond to changing requirements with workable deliverables and solutions. So the original Project Management Institute research into this map was about encouraging flexibility. So we welcome that flexibility, we welcome those changing requirements as we go through an advisory project. And the key to developing those workable solutions quickly to meet the requirements, apart from our own hard work, is to make sure we're communicating frequently with the rail operator and the different bodies within the rail operator, so that we understand how requirements are changing, why they're changing, and then we can respond to those as well. So another key to exploring into the unknown here, and this is an example we'll talk about later on, but the attention to technical excellence. We want to make sure that whenever we are developing solutions, we're still maintaining that high quality of technical excellence, even in the face of requirements change. And this is these sorts of solutions that we're developing can include design documents or safety assurance work or systems methodologies that we're maintaining technical excellence even when those input requirements change. But also not to neglect the basics. So when we're exploring this unknown area, we've talked a lot about the complexity of unknown, but to also not neglect the basics when we're out there, those fundamental passenger needs and the basics of rail systems. So we'll look at some examples of what this means, of how to walk through these steps. In our first example, we were looking at improving a maintenance specification for all the systems on a fully automated metro line. We were responsible for conducting an asset management assessment, for reviewing the asset condition and reviewing the outcomes of various audits which had been conducted. But there were hidden problems there that we didn't foresee. Was there anything lurking beneath the surface? So our starting point, our known knowns, where we always start, the things that we knew before we could look at improvements and possible resilience enhancements was to look at what we knew. So that's the maintenance specifications, pardon me, the passenger needs, the project requirements, the state of the assets, and the lessons learned, the rail operator's experience. So to work through some unknowns and to venture into the more complexity of unknown solutions, that was where our asset management assessment comes in and where we conducted our known methodologies to do an asset management assessment and to do an asset condition assessment and to conduct an audit. So those were the known techniques that we applied to try to add resilience to this maintenance concept. However, this didn't really give us the opportunity to enhance the resilience of the system because we were only looking at the problems that we knew about. We weren't looking at problems we didn't know about. So our exploration of the unknown then, our real opportunity to improve resilience came about when there was an incident on another line, a crisis incident, 2 trains collided. Luckily, no one was hurt, but this gave us the opportunity to push further into the unknown, to ask questions about how our solutions could possibly be affected and to allow our requirements to shift so that we could work with the operator to develop a more resilient solution for their maintenance. It brought new bodies into the conversation, new people that we could talk to about enhancing resilience. In our case, in this case in particular, our focus was predominantly on the prevention of disaster, but also in the processes and procedures that were used in the recovery of the line. And the incident on the other line gave us the opportunity to enhance the resilience here, and it really taught us the lesson that we shouldn't neglect any opportunity to enhance resilience. This was a validating lesson for our model that showed we could apply it in a variety of situations, even when we thought things were well defined. So our second example was about assuring an unknown solution. When we explore these unknowns, how do we know we're making the right decisions? So we were working with a mature rail operator who introduced some new technology, a new part of the signaling system that they'd prepared in an effort to enhance railway resilience. They were putting up a big blanket solution against all unknown areas. Their solution was intended to mitigate against all unknowns as a blanket approach, and it was a new solution to them as well. And there was a bit of concern that the enhanced redundancy was coming at too high of a cost, and they didn't know this was the right decision to make. So our goal here was to provide the rail operator with the assurance they were making the right decision. It's easy to throw out ideas into the unknown, and it's harder to provide solid assurance that you've considered that technical excellence when you do so. So that's where we came in. Again, we started with what we knew. We started with design documents and suppliers data, use cases, our previous experience of similar equipment. We knew all this information, and that was the start of building the case in providing this assurance. We stepped into more complex methodologies where we put together a benchmarking study. We compared with international railways. We uncovered case studies from those other railways as well, and used this to really complement that case study, the case for assurance, to give the operator the confidence they're making the right decision. But to really finish off that assurance, we had to push forward into the unknown areas. And in this case, we made sure we were maintaining a high attention to technical excellence. So we communicated frequently with the operator and asked for a lot of stakeholder feedback, a lot of opinions about how they thought about this equipment, about this new system, and then we made sure those were backed up by technical facts and had that high level of technical quality underlying opinions. We also made sure that we remembered the basics of how the principles of rail signaling, of how to move trains safely. So using this, we were able to provide assurance in the solution. We did find some caveats to the solution though. By asking those questions and going through that approach, we did find that while we were able to provide the assurance, there were some caveats. In our case, this new piece of equipment, it did enhance the pre-crisis resilience in the system, pre-crisis being that prevention and prediction, but it didn't support rapid recovery as much, particularly in scenarios where it was this subsystem that failed in a crisis. The rapid recovery wasn't great. This was down to maintenance access in the end. So one of our recommendations was to improve the accessibility of this piece of equipment so that it could improve the recoverability of the system and its resilience should this system be the one in the crisis scenario. So we've got a third example as well of this back to basics approach. And I'll pass over to Joseph, who was the lead on this one. So Joseph, I'll pass this third example over to you.
Thanks, Chris. So in our third example, we were asked to look at what went wrong with a complex solution that was employed to enhance resilience. So another mature operator we work with had just purchased an off-the-shelf software solution intended to enhance the resilience of their signaling system. To further enhance it, they had requested some additional functions from the supplier of the system, adding more complexity to it. As the solution was being deployed, it was identified that users of this solution, the operating staff, would have been put in an unworkable scenario due to the way the system behaved in certain situations. We were asked to examine the problem. So we applied our model again, this time conscious that the rail operator already had an extensive system intended to protect against crisis. We applied our model to analyze this complex system to discover and try to find workable solutions. Our first step in understanding the system was to backtrack to what we knew, the rail signaling basics. This is the known area. How to safely move a train. How to communicate the movement of a train to other trains. And lastly, the information operators expect to receive from the system, train position, and signal status. Our second step was to build our own model of how the system could still address potential crises based on these fundamentals. And our third step was to identify how the system could be modified to reduce that complexity. In doing so, we uncovered that there was opportunity to reduce the complexity of the system and its protection against crisis in favor of greater support for rapid recovery in a crisis event. Going back to the basics of how railways operate, through the application of our model, allowed us to simplify a complicated system and realize a fresh opportunity for enhancing resilience. So to wrap it all up, our model provided us with a structure that uncovers opportunity to solve problems of enhancing resilience. In summary, it walked us through from where we know to applying known methodologies that produce unknown outcomes, to asking those questions that we can use to uncover the things that we don't know. It provides a facility where a project can examine how to solve a problem when we may not know what the problem is. We've learned from the application of our model that the exploration of the unknown is important for enhancing resilience, that providing assurance is a necessary part of using unknowns when solving a problem, and that going back to basics and rethinking complexity can help us uncover better solutions. In our rail team, many of the opportunities that we have to advise operators on improving their railways have hidden, complex, or unknown qualities that could be drawn out for the benefit of the operator, particularly in enhancing resilience. We're sharing this model to spread the word and encourage rail engineers like ourselves to firstly think about how rail resilience can be enhanced. Secondly, and encourage engineers, railway engineers like ourselves, not to be afraid of the unknown. And that enhanced resilience can be planned for, including rapid recovery and assurance, while not neglecting the basics. So if you would like more details about the steps involved in our model, please get in touch. Otherwise, I'll open up the floor to questions. Thank you.
Thank you, Joseph and Chris, for a fantastic presentation. Chris, if you can go to the next slide, please. Thank you. So before moving into the Q&A period, I would like to remind attendees to enter a question in the question box on the GoToWebinar platform. And also you can download a PDF version of the presentation from the handout box on the dashboard. I will start with the first question. You have mentioned rapid recovery in a few of your examples. Can you go into more details about what sort of solution railways can employ to enhance rapid recovery?
Joseph, if you don't mind, I got some ideas for this one.
Yep, go ahead.
Okay. So rapid recovery, at a core, we find availability of competent staff is one of the themes in a lot of the advice we give for rapid recovery. So that competent staff, having staff that are trained in good recovery procedures, particularly in emergency response, and having those staff be available at the right locations at the right time. So having systems that support recovery. And are those staff able to use those systems to help? Are the systems simple enough for the staff to help in the recovery process? Thinking forward to the future of this one, I read an article recently by a rail system supplier about using artificial intelligence for decision making. I'd say post-incident, helping people prioritize their approach. It's probably a good rapid recovery solution that we should keep an eye out for in the future. Joseph, did you have anything to add?
I think it's again going back to the knowns, basics about what they know about the railway instead of tackling the system from its most complex solutions. That's rapid recovery. Again, it's going back to the model, really. Yeah, that's my answer.
Thank you. And next question, in your experience, what are the most common advisory problems you encounter?
I can start with this one, Chris?
Yeah, sure.
The most complex problems we encounter is when the client asks us, they start with an unknown, many unknowns actually, and ask us to derive from first principles, where such unknowns are actually staring them in the face that those answers are back to the basics. But because they are so focused on the unknowns, they ask, how do we solve complex solutions using unknown answers? So we have to tell them, let's go back to the drawing board and look at where your problems lie first. So we have to lead them back to what they know and why these problems exist in the first place. Yeah, that's a very actually that's very challenging when your client or the people who ask you solve problems tackling first thing from the unknown. Yeah.
Thank you. Next question, are there any metrics rail operators can use to measure and improve resilience?
I'll take this one if you don't mind, Joseph.
Okay.
Yeah, because we had a few recently. Cost of delay being able to calculate the cost of a delay is probably the first one I'd put up there. Because then you can compare, once you have cost of delay, you can compare your solution to however to the impact of a crisis event. So it gives you that comparison. Part of building the assurance case to make sure that you've come up with the right solution. A few others I've seen recently have been a passenger comfort change. So surveying passengers and asking them if they felt there was a big impact from certain crisis events, change in passenger travel time, and frequency of disruption as well, frequency and duration, because is there any significant disruptions, and building such a metric can allow you to compare your solution to see if it's appropriate to enhancing the resilience on the railway.
Mm.
Thank you. Joseph, would you like to add anything to that?
Oh, just one thing. One of the issues that we've found is some clients set their KPIs, key performance indicators, too high. So that might be a cause of the original problem. So there's no defined matrix as such, but you have to look at your KPIs. Yeah. Mm.
Thank you. The next question is, in light of COVID-19 pandemic, how can we still maintain a safe and healthy public transport system in a crowded city?
Okay, I can start, Chris.
Okay.
Okay, so it really depends on the city itself. Many and the railway itself. Railways are designed to operate differently to different cultures. Some stations are big, some trains have more air conditioning, others less. For example, in places that we reside, there are robots actually that spray out germ-killing liquids at terminal stations, and there's hand sanitizers available for passengers before they board the trains or when they get off the trains. Studies have also shown in the last year and a half that trains are by far the safest public transport when you compare them to buses and taxis. So I think there is certain levels of comfort that passengers can take when they go into a train system. Do you have anything to add, Chris?
Yeah, I was going to add on that we're exploring recently with a rail operator about ways to reduce touch on a passenger journey. And the two ideas that came out of this to reduce the amount of contact, common contact areas, was to consider using alternative ticketing technologies. So this was things like using QR code tickets or Bluetooth tickets, where we just walk through a barrier and it charges you automatically. But the other one we found interesting in this reducing touch workshop was to encourage smoother rides on the railway. So to implement appropriate track and permanent way maintenance, perhaps at a higher standard than had traditionally been used, to reduce the lateral forces on the train and make it a bit of a smoother ride, which could have the effect of discouraging passengers from touching common areas. We wouldn't go as far as to remove common handholds, but to encourage them that they may not have to touch anything when they're using the train system.
Fantastic. Thank you, Chris and Joseph, for a fantastic presentation. We don't have additional questions. We're at the end of our webinar session, so please feel free to contact Joseph and Chris via the contact details shown on the screen. And I would like to thank all attendees for joining today. Thank you for your time, and thank you for joining from all parts of the world. Thank you.
Thank you. Thank you.
I will wrap up the webinar now. Thank you. Have a wonderful day, everyone.
Thank you. Good night.
Thank you. Good night.